Okay, so in lesson 4.9, we're going to be looking at equations and looking at the slopes of parallel and perpendicular lines. When we learned about slope, we already learned that when we have two parallel lines, they have the same slope. When they are perpendicular lines, they have opposite reciprocal, meaning opposite signs, and then the fraction is going to get flipped upside down. So here we're going to be able to identify and graph parallel and perpendicular lines. We're going to be writing equations to describe lines parallel or perpendicular to a specific line. So what you'll do here is you're going to look at the equation. If they have the same slope, they're parallel. If they have opposite reciprocal slopes, then they're perpendicular. So the two vocab words here are parallel and perpendicular. If you ever see these two little straight lines, this is indicating parallel lines. If you see what looks like an upside down T, that is the symbol for perpendicular lines. Remember, perpendicular lines, when they intersect, they form a cross. So here is a word problem. Can anybody tell me what kind of lines these are? Are they parallel or perpendicular? They're parallel. Notice the two equations written in red and blue. Notice that they have the same number in front of x. What is that number in front of x? 3. And what does it represent? The slope. Good. So these two lines are parallel and they have the same slope. So it's just a word problem, and it says to sell at a particular farmer's market for a year, there's a $100 membership fee. And then you're going to pay $3 an hour for each hour that you sell at the market. But however, there's another place where the membership is only $50. So it's the same cost per hour, but one place charges more of a membership fee. So that's the difference between the two lines. So it's just a graph representation of a word problem. Yes? Okay, she had a question about the slopes of the vertical and the horizontal lines. Again, slope of a horizontal line is 0. Slope of a vertical line is undefined. So I don't know if I told you the trick before Christmas, but look at the words undefined. Okay? The first 3 letters, think of it as up, and the N could be and, down. So when your graph is up and down, so see how it's up and down here, it's vertical, the slope is undefined. So a little trick maybe to help you remember what the slope of a vertical line is. And then the slope of the horizontal line is 0. Okay, it's a flat line. When you put these two lines together, a line that's vertical with a line that's horizontal, together when they intersect, they're going to form perpendicular lines. And we're going to see that later on here in the PowerPoint. Okay, so here it says these two lines are parallel. They, when they're graphed in the same plane, notice there's no points in common. In other words, they're not intersecting. They're running side by side. So parallel lines will never touch. So here it is in words, and it's got a graph that matches with it. So two different non-vertical lines are parallel if and only if they have the same slope. All different vertical lines are parallel. Notice the equation for a vertical line. It's x equals, and then the number it's hitting on the x-axis. So whenever you see x equals a number, you know those are going to be two parallel lines. Same thing for the horizontal. Okay, if you had two horizontal lines running through this graph, let's say a green one here, and then a yellow one, the green and the yellow, the green, and where's my yellow? The yellow would also be parallel, but they're horizontal. Now, on the quiz next week, I'm going to give you a question just like this one, where I'm going to give you 4 equations, and I'm going to ask you to identify all of the lines that are parallel. So what do we need to look at in our equation to find parallel lines? What do parallel lines have in common in the equation? What's going to be the same? The slope. So I'm going to look at the 4 equations. I've got the first one here. Then I've got this second one, y equals x. Then I have y equals 5x plus 4. And then last I have this one. I need to look at the numbers in front of the x. So in my first equation, my slope of this one is 5 over 3. What is the slope of my second equation? This one right here. 1. Good. We don't see it, but there's an assumed 1 there. Okay? Then the blue one, what's the slope? 5 over 3. And then the last one, what's the slope of the red one? 1. Now, which, and let me number, or we'll just do it by colors. Yes?
What if there's no x in front of the number?
Okay, so if there's no x in front of the number, if it's y equals, then you're let's say it's y equals 5, then you're looking for another equation that has y equals, just a number. Does that make sense? Okay, so for example, if there's no x, so let's say it's y equals 5 and y equals 4. So when it's got the same thing where there's no x, then those are also parallel. Those would be horizontal lines. If it was x equals 1 and x equals 4, together, these are also parallel. Does that make sense? Okay. Now, back to this. My yellow, green, blue, and red. Which one is parallel to yellow? What color? Good. Which one's parallel to green? Good. Christmas. Okay. So, this is what you're going to have to do on the quiz next week. Now, if the equation is not in slope-intercept form, you will have to rearrange it into y equals mx plus b. You will have to do that on the quiz. This one we didn't. It was all in the correct form. But we'll see this in a few minutes. We'll do some examples. Okay, here's another example. Notice, let's go ahead and separate these by colors. So the first one I'll underline in black, then red, then blue, and then green. All right, now, what is the slope of the black line? 2. Everybody see that? It's in y equals mx plus b form. Okay, what about the red line? What's the slope? Negative 2/3. Now, blue line, is it in y equals mx plus b? No, it's not. We need to fix it. Okay, you can't just look to see the number in front of x. It has to be y equals. If it's not, we need to fix it. So let's fix the blue one. So 2x plus 3y equals 8. How can I isolate y? What do I have to do first? Subtract what? Nope. Subtract the 2x first. This is chapter 1 again, where we solved for variables. So now I have 3y equals negative 2x plus 8. Now what? I need y all by itself. How do I get rid of the 3? Divide. Good. All 3 pieces. So now I have it in slope-intercept. It's y equals negative 2/3 x. And I'm not going to divide the 8 over 3. I'm just going to leave it. Because for this, all I need to know is what the slope is. What is the slope of that line now? And my writing's kind of negative 2/3. So I'm going to write it up here. Negative 2/3 x plus 8 over 3. That's the blue line now. So let me highlight that slope. Oops, I didn't highlight. I scribbled on it. Okay, green line. Is it in, what form is that? Deanna?
Small question.
Yes.
Why you trying to rearrange an equation, you end up with y equals, except the slope and the x integer are switched over to next.
Okay, we need to rearrange it so that the y is all by itself, because that way when I move everything away from it, I get it in slope intercept form and I can identify the slope. I need to find out what number's in front of x when y is all by itself. I can't just look at the blue one and say the slope's 2. I need to move it to the other side and then divide by 3.
Okay.
Okay? Yes.
Okay, two things.
Yes.
One's in point slope, and then two, I think it's in point slope.
It is. Good.
And then two, can I go to the bathroom?
Yes. All right. Now, because it's in point slope, do I need to fix it, or can I tell what the slope is just by looking at it in point slope? Because I don't care if it's in slope intercept form. I just need to find the slope. How can I find the slope when it's in point slope? What number is or where can I find the slope? Anybody know what the slope is in this one?
3.
The 3 that's outside the parentheses. Beautiful. So the slope is right here. I don't need to rearrange it. All I have to do is find the slope, because all I wanted to do was pick out which lines were parallel. All right, so now I've rearranged them. I've identified that the slope in the black one is 2, the red one is -2/3, the blue one is -2/3, and the green one is 3. Which 2 lines are parallel? What colors? Which ones have the same slope? Red and blue. Okay, so these 2 equations, I'll highlight them in yellow. The red and the blue are parallel because they have the same slope. You will have questions like this on the quiz next week. You will have to rearrange it into slope intercept form first. You're going to have to work for it. All right, next one. Here's another example, or is it the same one? Same one. They were still working on it. All right, and here they've actually graphed the 4 equations. Notice if you were to graph them, you would have a visual to see which lines don't touch. And then 2 lines that do not touch are right here. They're really close to each other, but they're parallel. They never cross. Here's another question. Let's identify the slopes. Again, let me color it. So I'll do it red, blue, green, yellow. All right, what is the slope of the red line? I'm going to have to wake somebody up. 2. What's the slope of the blue line? What's the slope of the green line? Nope. 0. Okay, so this slope is 0. What's the slope of the yellow line? Undefined. Beautiful. All right, so now that we've identified the 4 slopes, which 2 lines are parallel? Nico? The first 2, red and blue. They both have 2s. Good? All right. Give us a graph to show. So here we can see the y, and it's 0, and we can see the x equals 1. It's the vertical line, and it's up and down, undefined. And all right, here's another one. Let's identify the slopes. Let's do red, blue, green, yellow. Okay, red, what's the slope? Can we tell it? Is it in the right form?
3/4.
It's 3/4. It's ready for us. Okay, what about blue? Is it in the right form? Not so much, right? We got to fix it. All right, so let's fix that blue one. So the blue one has negative 3x plus 4y equals 32. What do I need to do to get y by itself? I need to rearrange it. Move the x over first. Good. So plus 3x. So now it's away from the y. And now I'm going to divide everything by 4. So my slope-intercept for this is y equals 3 over 4x plus 32 over 4. Will 4 go into 32 evenly? How many times? 8. Okay, so now my corrected slope-intercept form is y equals 3 over 4x plus 8. All right, so what's my slope now? 3 over 4. What's the slope of the green line?
3.
Good. What's the slope of the yellow line?
3.
Okay, it's in point slope. I don't need to distribute. All I needed was the m. All right, now that we've rearranged, which ones are parallel? Which one? They're all, but not to each other. So which ones are parallel to each other? Which colors?
The red and blue and the green and yellow.
Good. Red and blue together, because they both have 3/4, and then green and yellow. Yes,
What if one slope is negative and one slope is positive?
they're not parallel.
Okay.
It has to be the same sign. Good question. Okay, everybody heard what she said? What if one's positive, one's negative? They are not parallel. It must be the exact same number. No opposite signs. All right, here's another example. Or is it the same one? Same one. They're working on rearranging it. Here is a graph of it, and then again we can see the two lines that are parallel. All right, now in the homework, you're going to have some questions like this where they're going to give you figures. It says use the ordered pairs and the slope formula to find the slopes of the lines. So what they want you to do is show that the sides are parallel by finding the slope of the ordered pairs and show that they have the same slope. Okay, you will not have questions on this on the quiz where you're going to have to show that it's a parallelogram, because this is sort of what you're going to learn in geometry. You're going to use the slope formula in geometry because you're going to have to show that a parallelogram has two pairs of parallel sides. And the way that you would show that is showing that they have the same slope. All right, let's get into the perpendicular. All right, perpendicular lines are lines that intersect to form right angles. So remember, perpendicular lines look like a cross. When they intersect, they're going to form a right angle. And actually, there's going to be 4 right angles. Each one of these will be a right angle here. Now, for perpendicular lines, remember the slopes are going to be opposite reciprocals. So, for example, the red line has negative 2/3. And the blue line has positive, flipped upside down, 3 over 2. When you see that the slopes, one is negative, one's positive, and they're reciprocals, you will know that those lines are perpendicular. The other type of situation where you do not have numbers in front of x are the vertical and the horizontal lines. This is a quiz question and a test question. Horizontal lines and a vertical line together form perpendicular lines. So when you see two equations and you see y equals a number and x equals a number, together they form perpendicular lines. This has a slope of 0 and this slope is undefined. So when you have two lines and you have the undefined and the 0 slope together, you know that those are perpendicular. This is on the quiz. Make sure you understand this. This is the question that everybody misses, because right now I got half of the class that's zoned out on me now. Okay? Horizontal and vertical lines form together perpendicular lines when they intersect. So here's our first example. We're going to color code here. All right, they didn't write it all straight in the same line, but I got one up here, it's blue. I got a green, I got a red, and I got a yellow. Let's go through and identify the slopes. What is the slope of the blue line? When it's y equals a number? 0. What's the slope of the green line? Undefined. I got some people that are awake bright and early this morning. That's excellent. Okay, what's the slope of the red line?
3.
Good, we actually got a number. And then the slope of the yellow line? Good. Now that we've identified the slopes, for perpendicular, we're looking for opposite reciprocals. So I'm looking for a positive number and a negative number together with the reciprocal. Or I'm looking for the undefined and the 0 together. So which, Paulina?
Can't you make the 3 into 3 over 1?
Correct, you could. And then that way you could see the reciprocal if you'd like. Okay, so which two lines are perpendicular? What colors? Which colors? Blue and yellow?
Not blue and yellow, red.
Red and yellow, good. And then what's the other pair?
Oh, the Y. Oh, wait, the blue and green.
Blue and green, good. Okay, so red and yellow are opposite reciprocals, and so are blue and green. This is a quiz question. I'm sorry?
Is it because they have negative signs or?
Because one has negative, one has positive, and then it's reciprocals. So like Paulina said, on the red one, put a 1 under it, so then you can see how the 3 over 1 and the 1 over 3 are reciprocals. And one's plus and one's minus. Then the other situation, and that's the hardest part for everybody, are the undefined and the 0 match. They make perpendicular also. They're just doing the same problem here. Here's a new one. Red, blue, green, yellow. What's the slope of the red line?
-4?
Nope,
No.
0.
0.
What's the slope of the blue line?
5.
Good. Oops, I need highlights. Okay, what's the slope of the green line?
0.
Nope,
Undefined.
undefined, good. And then the slope of the yellow line?
-1.
Good. All right, where are the perpendicular lines here? Which colors? Paulina?
It's blue and yellow and green and red.
Good. Blue and yellow, green and red. Perfect. Nice.
0.
No, it's when it's y equals a number, it's the horizontal line. So see, the graph is here in blue, actually. So whenever there's not an x in the problem, then the slope is 0.
Oh.
So when you don't have an x anywhere in your problem, the slope is 0. Okay. Same question. Yes, question?
If it's a negative, that's
Okay, this is the graphs. All right, again, yes, question?
What if all the slopes are positive?
If they're all positive, then you know you're not going to have any perpendicular ones in there.
Okay.
You need one negative, one positive. All right, here's another example in a relation to a geometry application. They wanted to know if it's a right triangle. A right triangle has a 90-degree angle, so you would find the slopes of the lines. You would look to see that you would come up with an opposite reciprocal. Notice when they found the slope of this side, the AB, and then the slope of the AC, together they made opposite reciprocals, so it was perpendicular, making it a 90-degree angle. Again, I'm not going to quiz you on the geometry application here, but you will be doing this next year. And here's another geometry application. All right, so same stuff that we did last night. Now we're going to do it with an equation here. So it says, write an equation in slope-intercept form that's going to go through this order pair, but it's going to be parallel to this. Now, when we did the homework last night, remember they gave you a slope, and then they gave you an order pair. All right, so for this one, I need to find the slope that would be parallel to this. What do we know about parallel lines? What do they have in common? What's the same? The slope. Good. What is the slope of the line right here that I put next to my arrow? What's the slope there? 3. So if I need a line that's parallel, I'm going to use the exact same number in the equation that they give me. So the slope I'm using is 3. The order pair they give me is my x1, y1. Now I'm going to do exactly the same thing that I did in the homework the last 3 nights. I'm going to take this information and I'm going to put it into point slope and then distribute to get it into slope-intercept form. So I'm going to do y minus 10 is equal to 3x minus 4. Same thing I've been doing the last 3 nights. I'm now going to distribute. And then move the 10 over. And I get y equals 3x minus 2. This is an equation that will have this order pair in it that is parallel to the first equation. So all you're basically doing is if they want something parallel, take the number in front of x and use that as your slope and do it the same way we've been doing the homework the last 3 nights. What would I have used if I said a line perpendicular? What would have been the slope I would have used if I asked for perpendicular? What would have I done to that 3 to make it perpendicular? No?
I have to put in the -3.
Make it a reciprocal and make it negative. Good. So if I said perpendicular, we would have flipped this, the 3 over 1, made it 1/3, and also made it negative. So if the question said perpendicular to this line, make it negative or opposite sign and a reciprocal. Yes.
What's reciprocal again?
Reciprocal is a fraction flipped upside down. Okay? And if it's a whole number, turn the whole number into a fraction by putting a 1 in the bottom. Let's look at another example. Same example here. All right, here's a new one. Okay, it wants us to write an equation in slope-intercept, and here we go. They've changed it. They want perpendicular. What is going to be the slope that's perpendicular to 2?
-2.
Negative, flip it upside down. Negative 1/2. And then now my order pair here, that's up here in the problem, that's going to be my x1, y1. And then do the same thing you've been doing with the homework. So y plus 1, negative 1/2, x minus 2. They want slope-intercept, so you distribute. And then move the 1 over. And actually, it just becomes y equals negative 1/2 x. Good so far? See what else we got here. We're almost done. All right, so here they've done the problem that I just did on the other slide. Okay, so now, if you know the slope of a line, the slope of the perpendicular line is going to be the opposite reciprocal. So here's some examples of opposite reciprocals. So notice when it's already a fraction, flip it upside down, make it negative. Okay? Here, they just took the 1/5 and they turned it into 5. Know that you could have put a 1 there if you wanted. And then when it's the whole number, remember you put the 1 there to begin with and then flip it. Good so far? Okay, here's another example. They want parallel. So what is the slope of this line that I'm highlighting in red? 4/5. When I want something parallel, what slope am I going to use? Nope. I want parallel. You guys gave me perpendicular. So I keep it the same. It's 4/5. Remember, parallel, you use the exact same number. Perpendicular is when you flip it and make it negative.
So if 4x and 4x are parallel?
Yes. All right. So here, I'm going to use the 4/5, and then I'm using the order pair. So y minus 7, 4/5, x minus 5. Distribute. I get -4, and then move the 7. And that's it. See, the next probably has the work. There we go. Same thing that I just did. Okay, here again, now they're switching it to perpendicular. What slope am I going to use for perpendicular if the given one was a 5x? -1/5. Good. Flip it and flip it. Make it opposite sign and flip it upside down. And then put it into point slope. And that is the lesson for today. Any questions?